let f of x be equal to the square root of 16 plus 6x minus x squared for x between 0 and 8. The graph of this is shown below. In order that the inverse function is a function, the domain of f must be restricted to x between k and 8. Explain why this restriction is necessary and state the minimum value of k. So, it's necessary because f needs to be 1-to-1 for the inverse to exist, at least to exist as a function. Now, somewhere like 6 would work. This function is definitely 1-to-1 here, but it does ask for the minimum value. So what we need to do is go to the maximum there, and so we'll say that k is equal to 3. Now, using the restriction from part A, determine the inverse function of f and its domain. So, from above, we have that y is equal to the square root of 16 plus 6x minus x squared. Now, interchange x and y. So we get the square root of 16 plus 6y minus y squared. And now what we want to do is make y the subject. So, let's square like so. Now, one thing you could do is bring everything to the left, and then we have y squared minus 6y, and we would have plus x squared minus 16 is equal to 0. Now at this stage you could use the quadratic formula, or you could complete the square. I'm going to complete the square, so I'm going to say, well, this one is y minus 3 all squared. Take away 9, and then we have plus x squared minus 16 equals 0. So y minus 3 all squared would be equal to 25 minus x squared. And so y minus 3 would be plus or minus the square root of 25 minus x squared. And then y would be equal to 3 plus or minus the square root of 25 minus x squared. Now, because of the way that we set this up, with the domain going from 3 upwards, that's going to mean we need the positive. Therefore, we can say that the inverse function is 3 plus the square root of 25 minus x squared. The domain for that, if we go back to the graph, needs to be the same as the range of the original function. So the domain would be for real values between 0 and 5.